Hi, this is a continuation of what we did last time. And let me clear the screen first. This is the virtual server. I just logged in as root on the virtual server. The first thing we want to do is to take a look at several pieces of information regarding LVM, Logical Volume Management. The first thing is to use PV display to show us all the physical volumes that the system can find. At this point, there's only one because we only have one hard drive or one partition that is configured as a physical volume. That's our first hard drive, SDA, and the second partition of that hard drive, SDA2. It is assigned to a volume group, which is VG0. A physical volume can only be assigned to one single volume group, or it can be unassigned. In this case, it is. The size of the physical volume is 1.91 gigabyte, and the physical element size is 4 megabytes. So that means every time we allocate, it has to allocate in increments of 4 megabytes. There are 487 4 megabyte elements in it, and there are 83 available at this point. And the physical volume UUID is this mess here. Okay, the next item, or the next thing, this is the lowest level construct when we are talking about LVM because it is a physical volume. The next one up is called a volume group, VG, and we can also use VG display to show us information of all the volume groups that are active at this point. And we only have one, which is VG0. It is formatted to LVM2. And it shows us all the other information about the volume group, such as there are 6 logical volumes at this point, and all 6 are open at this point. It also shows us that we have 4 megabyte as a physical element, which means we are allocating by 4 megabytes at a time. It shows us, it's basically the same information as the previous screen. Now, this one only has one physical volume associated with it. You can tell from here. But each volume group can have multiple physical volumes associated with it. And this is really handy because what happens is if you run out of space on one single hard drive and you don't want to buy a new hard drive and then move everything over to the new hard drive, one way to do it is to attach another drive to your system. When you attach another drive to your system, you cannot expand the previous physical volume to include the other drive. You have to create another physical volume on your new hard drive. But what you can do is to associate the new physical volume to a volume group that is already existing. Therefore, you are expanding the size of a volume group by adding another physical volume, and the physical volume is on another drive. Now, this is really crucial because everything else is built upon VG or a volume group. So now let's take a look at the top level of LVM, which are volume groups. And this time I'll pipe it through less so that we can take a look at the multiple logical volumes that we have created. This should look familiar. Our root mount point is using the root file system, which belongs to volume group 0. And you can tell that the logical volume size is 188 megabytes. We call for 200 MB, but that's in a metric unit MB, and this one MIB is in 2 to the power of 1 mega is 2 to the power of 20. And that's why it shows a slightly different number here. It also shows us the read-ahead sectors is currently set to 256, which basically means it will read 256 sectors ahead of time, even though we are only accessing the first one, or one, and then it will read the next 256 sectors. And then we have the other ones like home, user, var, and temp, and also our swap volume. Now, all of these are logical volumes, and every single logical volume allocates its space from a volume group. and every PE or every physical element inside the volume group can be assigned to any logical volume. So that's why we have this one item here called segment. It's basically telling us is this particular logical volume broken up into multiple segments from the allocation from a volume group. In this case, it is not broken up, it is a single segment, which is good. Because potentially it can be broken up into multiple segments, which also means the file access to that logical volume can be a little bit slower because physically the segments are disjoint. Okay, now let's go ahead and do something that's easy first. What we want to do is to use df-h to show us how much space is used on each volume that is mounted at this point. We can see that user is, well, we have used up quite a bit of that. We have used up 60% of that, and let's just say that we want to make it bigger. Okay. To make this bigger, we have to use a command called lv-extend, and if you just type lv-extend, it will show you that it doesn't work by itself because you need to supply some parameters. If you supply --help, then it will show you the online help. The online help is telling you that the format is you have to specify which volume, and then you have to specify how you want to change it. There are several really. Okay, this is the required part, is the logical volume. And then you have to supply one of these other things to say that you want to make it bigger, smaller, or whatnot. And what we want to do is to use one of these two, -lowercase-l or -uppercase-l. One extends by a percentage. The other one expands by a particular size. So if you use -uppercase-l, which is equivalent to --size, you have to supply either the absolute size of the new, you have to specify the new absolute size, or you can say I want to add this much volume size to the partition. Okay, so let's take a look at the, df-h again. We can see that /user is currently 461 megabytes, and which is equivalent to 500 metric megabytes. And I believe the other one uses the physical. Uses metric units. And just to be sure, we'll go ahead and read the full help of this. And we have this part here, M for megabytes, and if it doesn't say that it is MI instead of M, it is in metric units. So in this case, we have 500 megabytes already allocated to that particular volume. So let's go ahead and do this. lv-extend, and then we specify the volume itself, which is in VG0. It is USR, and then we specify -uppercase-L, and we want to add, let's just say that we want to add 20 megabytes to it, which is not a whole lot. I know this is not significant at all, but I'm just using this to illustrate how to use that command. And it says that the logical volume user is now extended to 496 MIB. In this case, MIB is a non-metric unit. This is 2 to the power of each MIB is 2 to the power of 20 bytes. Okay. Now, just because we have extended the logical volume, which is where the file system lives on, doesn't mean the file system is automatically resized. So what we could have done is to use -r, lowercase r, to trigger the resizing of the the actual file system. But we didn't do that. That means we actually have to do it again, because let's take a look at this. df-h, and we look at user. Hey, it is still 461 MIB. How come it is not extended to 496 MIB? And the reason is because even though we make the lot size bigger for a property, we did not change the size of the house to make use of the extra lot size for that house. Okay, so what we need to do now is to say, okay, I want to expand the house to be the same as the lot size. And the command to do that is resize e2fs, which only need one mandatory parameter, which is the path to the partition itself, to the volume, in this case, to the logical volume. So it's in device vg0 and USR, and then you press the enter key. It shows that it is currently mounted. Online resizing required. Performing online resize of this particular volume to 507904 1K blocks. It is now that size. Now, normally, if you're expanding a volume, you're not going to expand it by 20 megabytes, which is insignificant. I'm doing this, just so that we can get through the illustration really quickly. So after this step, when we use df-h again, you can see that this time it is now expanded. It is now 481 MIB. In this case, it's in 2 to the power of 20 units and not in metric units. So that's how we expanded the size of the user volume. And you can see that there's no need to reboot the machine when you're changing it to be bigger. Now, what if we want to change the size of a partition to be smaller? Well, that turns out to be more troublesome, because the online resizing, which you see here, cannot work with shrinking a partition. I think that actually makes sense, because when you shrink, most of the time when you're running a server, you are resizing because you want to make a volume bigger and not smaller. And so, the inability to resize a partition to make it smaller is not a big deal, because most of the time you want to make it bigger and not smaller. But then, if we want to shrink a partition to make space for another partition, for instance, right here we have /var, and that is only using 25% of the available space. Of 461 megabytes is only using 107 megabytes, and so it doesn't really make sense to make it waste all that much space. So if we want to change the size of this partition, we cannot do it when the system is running, because the partition is actually mounted at this point. Now we can go ahead and try to do this. Now what we do not want to do is to use LV extend first to change the size of the logical volume, because the logical volume is the lot size, and the file system size, which you see with df-h, that's the size of the house, the footprint of a house. If you shrink the lot size before you shrink the size or the footprint of a house, you are in trouble, because your house is now taking up more space than it should. So what we need to do is to shrink the size of the house first, and then we go back and shrink the lot size to match the size of the house. So the order of shrinking is going to be different. We have to resize the partition first. So in this case, we have to say resize e2fs /dev/vg0/var, and now we want to say, okay, how much space do we want to allocate to this? Let's just say that we want to allocate 200 megabytes. Okay, this is the command to say that we want the size of this particular file system to be 200 megabytes from now on. We press the enter key, and it says, well, guess what? Online shrinking is not supported. Okay, now if you cannot change the file system size, you should definitely not try to change the logical volume size, because that's just dangerous. Okay, you can try that and the system should come back with an error, but you should not even give it a try, because we know that that's a dangerous operation. So the question is, what do we do if we want to shrink the size of a partition? There are several ways to do it. The more complicated way but you can do this remotely, which means you don't need physical access to the system, is to change the init RAM FS, the the initialization RAM file system, which is the kernel that runs before it boots to the actual kernel. But that's really quite complicated, and if you mess up, your remote system can be hosed to the point that it cannot start up again. So that's dangerous. That's really quite dangerous. The other thing to do is to have physical access to the system, and then we can restart the system using excuse me, using the CD-ROM, the live image, because the live image, the installer, also has a mode to rescue the system instead of installing the system itself. So we'll go ahead and try that approach right now. We'll go ahead and reboot the system, and I have to be ready to press the F12 key to catch the BIOS screen. So now the system is rebooting. And oh, okay, I see. Because my virtual machine did not have the CD-ROM installed or the CD-ROM attached, so I will have to break this up and start another screen capture to show you that part. This is the end of part 1.